In this video, I'm going to be talking about the law of sines, which is going to be kind of a faster way to solve out some triangles that we've already been working on. Specifically, if you watched the last video on inverse trig, we solved out some obtuse triangles, and some of the things were a little labor intensive, and this is just definitely a shortcut for that. If you were in my pre-calc class last year, then you saw the proof for the law of sines, but in the interest of time, to keep this video short, I'm just going to give you the law, show you how to use it, and give you a few examples, So here we go. So before I give you the law of sines, I'm going to just talk about, some triangles. And so I want you to think about a triangle that has got a really, really narrow angle, right? Just like that. Okay. Well, the side across from this really narrow angle is going to necessarily be pretty short, right? I mean, unless one of the legs was way, way longer than the other. But even still, okay, if it was just like that, small angle can correspond to a short leg. And keeping the same idea, if I had like a really obtuse angle, like that, and I had a really wide angle, the side across from the wide angle would be pretty long, right? So in some way, there's a relationship between the width of the angle and the length of the leg across from it. Okay, this is the law of sines. Okay, so here's the theorem that relates the width of the angle to the length of the leg across from it. For any triangle ABC, sine of A over A equals sine of B over B, which is also equal to sine of C over C. So the ratio isn't necessarily the degree measure of the angle to the side length. It's the ratio of the sine of the angle to the side length across from it. Okay, that is the relationship. Okay, so this is the fact that you need to know, say for the quiz next time, for the upcoming test, final exam in this college algebra course is going to be just a trigonometry exam. That's the thing you need to know. And if you were in my pre-calc class last year, which I know a couple of people were, you saw this, and you saw that these problems were super friendly. Okay? They always kind of worked the same way. We're not going to do the ambiguous case in this class, so really there's only kind of two ways this can play out, and both of them are friendly. So let's take a look at an example. All right, for our first example, we've got a triangle where we've been given two angles and one side. And so I'll call this is not, I guess this is angle side, but that's the same as angle side angle. We knew that from the very beginning of our discussion of triangles that if we had the shape of the triangle in one leg, then we knew everything there was to know about the triangle. Okay, well, I've got the shape because it's 33, 67, and I would think 80. Yeah. And one leg is 5. So we could figure out everything there was to know about this triangle. We just have to, up to this point, since it's not a right triangle, we would have had to draw an altitude and split it up into two right triangles. But we're not going to have time for that, right? We're going to want to do this much faster. So what we're going to do is we're going to use the law of sines to find this side length, and I'll call it x. So we're going to solve for x using the law of sines. So what I'm going to do is I'm going to set up for the law of sines, where, the sine of 33 over 5 will be equal to the sine of 67 over x. So sine of 33 degrees divided by 5 is equal to sine of 67 degrees divided by x. Okay, I'm going to cross multiply. So I'll have x times the sine of 33 degrees is equal to 5 times the sine of 67 degrees. And then to solve for x, I'm going to divide both sides by the sine of 33 degrees. So I've got x equaling 5 times the sine of 67 degrees divided by the sine of 33 degrees. Okay, now this is definitely a job for the calculator. All right, so what we're going to do is we're going to type in, we're going to ask for a fraction bar. Oh, looks like it's in the wrong mode. Okay, if you're working with this scientific calculator and it's not giving you a fraction bar, it's because you're in classic mode and you need to go to math print. All right. So what we're going to do is we're going to set up a fraction bar. We're going to do 5 times the sine of 67 degrees. We're going to divide by the sine of 33 degrees. And we'll get 8.451. All right. Now, if we wanted to find, you know, the other angle and the other side length, which is something that we might actually want to do, I think I might actually do that on this example. So I'm going to find the other angle and the other side length. So I guess I'll call this y, and we'll just need to figure out what this angle theta is. All right. So I moved the previous work off to the side. Okay, theta is going to be 180 minus 66 minus, or 67 minus 33. Well, 67 and 33 add up to 100, so I'm basically subtracting 100 from 180, and that'll be 80. So what I should do is you should always use the information that you're given in the statement of the problem, not the information you solved for, because what if you made an error? You know, you want that error to propagate forward. So what we're going to do is we're going to use law of sines, but still with the 33 degrees and the 5. So sine of 33 degrees divided by 5 is going to be equal to sine of 80 degrees divided by y. Okay, so once I cross multiply and then solve, I'm going to end up with y is equal to 5 times the sine of 80 degrees divided by the sine of 33 degrees. Now, this is the type of thing that you could type into the calculator just like I did earlier. In the interest of time, I'm just going to leave it like this. Okay, I'm going to say that you definitely can figure out what y is. You can figure that out. Okay, next we've got an example where you are given 2 side lengths and an angle. Now, generally, I mean, in the bigger picture, this angle side is the case that they warned you about in geometry class, but this one is just going to be one triangle. What can happen is there can be 2 triangles that fit these specifications, or no triangles that fit these specifications. But just have faith. This one does work. Okay. Ideally, we have angle or angle side, where the angle sits between the 2 given sides. That's always one unique triangle, but that's kind of a different discussion. What I'm going to do is I'm not looking for side length x, although we can definitely find side length x. What I want is I want the measure of angle theta. That's what I want, right? So I'm going to use the law of sines to find the measure of angle theta. Okay, so I know that sine of 47 degrees divided by 6 is equal to the sine of theta divided by 7. So what I'm going to do is I'm going to try to solve at theta. Okay, so I'm going to cross multiply. 7 sine of 47 degrees equals 6 times the sine of theta. So if I were to solve for the sine of theta, that would be sine of theta equaling 7 times the sine of 47 degrees divided by 6. Right? Meaning that then theta is inverse sine of that fraction. Okay, so you're going to bring in the calculator. You're going to type it in just like you see it. Okay, so I'm going to do inverse sine. And I'm going to do fraction bar. 7 sine of 47 divided by 6. To get 58.566 degrees. 58.566. Okay. Now, if I wanted to find x, what I would do is I would, subtract. I'm not going to do it for the sake of time because I'm really running out of time in this section of college algebra. But what you would do, let me get this calculator out of the way, is you would find this angle, whatever it is, call it angle A, by subtracting 58.566 and 47 from 180, and then doing law of sines with 47 and 6, and then A it is. This is something we could do. All right. The third example I've got for you is the one that talks about an isosceles triangle. This is a little later on in your note packet. Okay, it says triangle UVW is an isosceles triangle. So I'll try to draw an isosceles triangle. I guess since I've got the grid up, this should be not that hard. Okay, so 3 in each direction, and then. All right, the base is 425 feet. So I'm just going to put that 425. The legs meet at a 39-degree angle. So I'll just call this a 39-degree angle. And find the length of the legs. Well, this is law of sine, so I'm going to want to use sine of 39 and 425. And you're going to have to think all the way back to the very first lesson of this unit when I was talking about an isosceles triangle. If we know one of the angles, we can find the other two, because that's theta, and this is also theta. So 39 plus 2 theta will equal 180. And this is probably not the best choice of numbers for this problem, because 2 theta is going to need to be 141, which means theta will be 70.5. Okay, ideally, that would be an integer, but, we can live with that. Okay, what we're going to do is we're going to set up for the law of sines, because the leg that I'm looking for is this, let's call that L, Okay, so I can say that the sine of 39 over 425 is equal to sine of 70.5 divided by L. So L, I lost my place, got distracted. L is going to equal 425 times the sine of 70.5 divided by sine of 39. And that's the type of thing that you can solve using the calculator, and I trust that you would be able to get back to. Okay, and the last example I've got for you is this guy wanting to measure the height of a tree. And if you look carefully, you'll see this example in the note packet and the practice problems. So it might be safe to expect that it's going to show up on the quiz and probably the test too, right? Okay, rather than reading you the whole, or writing down the whole problem, it's pretty wordy. I'm just going to kind of draw the diagram. I'll read it and then I'll draw the diagram. Ron wants to measure the height of a tree. He walks exactly 50 feet from the base of the tree and looks up. The angle from the ground to the top of the tree is 18 degrees. This particular tree grows at an angle of 87 degrees with respect to the ground rather than vertically, which would be 90 degrees. How tall is the tree? Round to the nearest inch. Okay, so what I'm going to do is I'm going to say, well, I'm going to draw this tree that's leaning a little bit. Maybe it's, here's the stump or the base of the tree, and there's the top of the tree. Something like that. Okay. It's making an angle of 87 degrees with the ground. Okay. Ron is this guy, and we're not going to consider how tall Ron is or what his eye level is. We're doing about that. Okay, and he's looking up, and this figure definitely not drawn to scale, but okay, I'll just give it some greenery to make it look like a tree. And this is 15 degrees. Okay, that's 87 degrees, and we said that he walked 50 feet away. Okay, so I'm going to use the law of sines to find this height, which I will call h. So, but I don't have the right angle. I don't have this this green angle, this angle across from 50. And that's what I need. So I'm going to do some work to find theta. So 15 plus 87 plus theta equals 180. So that means that theta will be 180 minus 15 minus 87. which I think is going to be, let's see, 87 and 15 is 102, so that'll be 78 degrees. All right. So what I'm going to do with that is I'm going to set up for the law of sines. So I'm going to say the sine of 78 degrees divided by 50 is going to equal the sine of 15 degrees over h. And I'm going to cross multiply. And then I'll solve for h.
No.
All right, and then I'm going to pull in the calculator, and I will calculate that. All right, there we go. So h is going to be, I'm going to put in the fraction bar, I'm going to do 50 times the, where am I? There I am. Sine of 15 degrees divided by the sine of 78 degrees. And I'll get 13.230 feet. All right, so a somewhat tall tree. And that's all the examples I've got for you in this video. I think, you know, there's a lot more examples in your note packet, and those would be helpful for you for practice. But these are the skills you need. So any of the other problems, they are just like the ones I've done in this video.